This exercise is all about equating coefficients, which you looked at a little bit in methods. So with complex numbers, it's pretty simple. If we have something like a plus bi, and we know that that equals 4 plus 2i, then we can break it up into the real and the imaginary. Okay, yes, that's my funny I. You can write just capital I if you want to. Just change that thickness because that's annoying me. Okay, so really all we're saying is what's the real part on the left hand side. So the real part is your a here, and on the right hand side it's the 4. So therefore we can say that a must be 4, and then our b is the imaginary part. Now the only thing that you have to be careful for here is make sure that your imaginary, you just look at the coefficient, you ignore the I. The I tells you that that is the imaginary part, right? So therefore b is 2. And I can say it's that simple, except your challenge is going to be that it's not always going to be in this cute form where it's simple, this equals this. You're going to have to do a bit of fiddling to maybe expand this side or even this side and then equate. All right, so let's have a go at some of these. So these are the 2 examples that we're looking at in our book, and they look similar except for one major difference. If you notice example A, the x and the y are all together in the one bracket, okay? Whereas over here for part B, the example B, your x's and your y's are separated. So we're going to approach these in 2 different ways. Now, the second method is going to work for every type, but when we've got it like this, when you've got that all in one bracket, the easiest way to do is to say, well, I'm going to get rid of this times 2 take I, and we've just been fiddling with all of that stuff, and we know that we can do that easily. So we'll say we get rid of the times 2 take I, we are going to divide by 2 take I. No, hang on, that's not very nice because we're not allowed to have imaginary numbers downstairs. So to get rid of that, we're going to multiply by its conjugate. Okay, and once we do that, what we're going to end up having, so minus I times 2, we've got minus 2i, and then we've got minus I times positive I, so that's minus I squared, right? So minus I squared, but I squared is minus 1, so we get minus minus becomes a plus 1. Downstairs we're multiplying by the conjugate, so that becomes 2 2s are 4, the middle terms disappear, again minus I times I gives me minus I squared, which is positive 1. So now we've got x plus iy equals minus 2i plus 1 over 5, and so now we're equating our real terms. On the left hand side, the real is the I, is the x, and on the right hand side, your real is the stuff without an imaginary, without the I, so it's your 1/5. Okay, so that becomes 1/5, and your imaginary y is on the left hand side. And what's the coefficient of your imaginary on the right hand side? It's not just minus 2, it's minus 2 over 5. Okay, I think that's pretty easy. Now, you'd like to do the same thing here, and you want to try and say, oh, let's get rid of that times 1 take I, but you can't, because when you've got this y on the other side, it's going to make life a little bit different. So we change tactics a little bit, and we multiply. So we're going to expand the left hand side, and we end up with x take xi, 2i times 1 is 2i, 2i times minus I is positive 2. Okay, so it's a simple expansion. And now all I do is I go, right, let's look at the real on the left and the real on the right. If you look at the example that they've done, they sort of pull out the common factor of I and group all their terms together. Okay, that's just extra work. So on the left hand side, your real is your x and your 2, and on the right hand side it's 5. So that's a simple matter. We can now just say x plus 2 equals 5, And therefore, I can now say, well, that means x is 3, right? And if we change that up a bit, we can go with the green, and we can say the imaginary, should have dotted my I there, the imaginary, right, be careful, it's not just x, it's minus x, the whole thing in front. So your imaginary on the left-hand side is minus x plus 2, and on the right-hand side, it's y. Now we've just figured out that x is 3, so that becomes minus 3 plus 2 equals y, and y equals minus 1. You can probably predict about what's going to happen now is that your equations that you are wanting or given to solve at this point, they might not always be very pleasant like this. So it might be, instead of x plus 2 equals 5, it might be x plus 2y. And then, oh, I've got simultaneous equations, well, let's solve simultaneously, etc., etc. Okay, so you have a go at the next questions. What I'll do is I'll just talk through the next lot of questions, and you can then stop the video, you can skip along, you can do whatever you want. Okay, starts off nice and simple. So once again, let's look at our, it's already expanded and everything, so we're just going to look at the real and the imaginary. So on the left hand side, the real part is the stuff without the i's, so that's 2x. So 2x equals, on the right hand side, the only thing is minus x. Now you can look at it right then and there and figure out there's only one number that times it by 2, it'll equal the negative of that number. All right, do you know what that number is? And if you don't, then just do normal algebra. Get rid of your take x, you add x to the other side, and we get 3x equals 0. And then we know, the only thing that x could be is 0. Okay, we do the same to the imaginary. On the left hand side, right, your imaginary is here, so that's 3y. And on the left hand side, your imaginary is minus 6. So therefore, y equals minus 6 divided by 3 is minus 2. Keep on going, same way, real. So again, pause the video whenever you need to. On the left hand side, your real part is x squared. On the right hand side, it's 4. So to get rid of the square root, to get rid of the squared, we square root, which gives me plus or minus 2. You don't stop there, we keep on going, because then if we look at the imaginary, even though we've still got x's, the imaginary part tells us that x must be minus 2. That means it can't be the plus or minus. All right, it's just 2. So you need to finish off and say, well, therefore, the only value that x could be is minus 2. So it started off that there were 2 possibilities, but then we looked at the requirement of the imaginary, and that meant that it could only be one of those values. Okay, sometimes it's possible that you can have 2 solutions, but in this case, we qualified that second one with this. Okay, now this one is a bit more like the example. I remind you again, I won't do it last time I remind you, but stop the video if you want to. To get rid of that times 2 take I, and we can do that because the x and the y are all together in the one bracket. If they're not, I would have expanded. Okay, now we get rid of the x plus yi equals 8 plus I all over 2 take I. And now to get rid of the 2 take I down the bottom, we're going to times by the conjugate. Okay, if you get tired of doing this, you could even just pop that into your calculator, but remember you're going to have a non-calculator test. So 16, we got 8 plus 2i is 10i. Take 1 because I times I is I squared, and downstairs once again we're left with 4 plus 1. So we've got x plus yi equals 15 plus 10i over 5. And therefore when we equate our real and imaginary, because we could simplify this to be 3 plus 2i, we've got x equals 3 and y equals 2. Done and dusted. Okay, same thing here. To get rid of the times 3 plus 2i, you need to divide, so you can do that. I don't think I need to do that one. Okay, question 2. So first thing we're going to do, it's a bit silly to get rid of that times 2 by dividing, so we'll just expand. So on the left-hand side, we've got 2x plus 2yi equals x. Take yi, we do the same thing, right? Equate the real, the imaginary, you've got this. The left-hand side is 2x, the real part. The right-hand side is x. We did a similar one like this before. The only number that if you times by 2 equals itself, that's got to be 0. But again, if you couldn't see, get rid of the plus x, take x, you'll end up with x is left with 0 anyway. Bang, you're done. And then the imaginary, okay, we've got 2y on the left equals minus y on the right. And once again, we've got y equals 0 to get rid of the take y, add y. So a bit of a silly question to start with. Anyway, okay, going on to B. So this one, once again, you can't get rid of it by dividing or anything like that. So our only option is to expand. Okay, so we end up with xy minus xi plus 2yi. Positive times a negative is a negative, but remember you've got that I squared, so it turns it into a plus 2. And on the right hand side, we just write our minus 4, take 7i. Okay, here comes the equating bit. So the real, the imaginary on the left hand side, right? I think you can see what all of your real and imaginary parts are, right? So your real is here and here, and there we go there. So we have xy plus 2 equals minus 4. And then what's our imaginary? Remember, ignore the i's. The i's just tell you that's the imaginary part. So it's minus x plus 2y, right, equals minus 7. So we've now got two equations with two unknowns. This becomes a purely algebra thing to solve. It's not as simultaneous as in do elimination or anything like that, but we can do substitution. So I'm going to rearrange this equation, obviously, to get x by itself. So I hope you agree that if I do this, I keep the 2y there, the 7 comes over, becomes plus 7, the x goes on the other side, I've got x equals 2y plus 7, and I'm going to substitute that, right, into x here. So now that becomes 2y plus 7 times y plus 2 equals minus 4. You can happily expand this now. I've got 2y squared plus 7y. Bring the minus 4 over. Why? Because I can see it's a y squared. It's a quadratic. So that means I am going to try and factorize this. Okay. By all means, you can go to your calculator if you want to. But simple ones like this, we should be able to factorize without using technology. So there is no common factor of 2. So the only way we can get a 2y squared is to say 2y times y. Now the factors of 6 are 1 and 6 and 2 and 3. And we want 7 in the middle here. Okay. And I'm thinking straight away, 2 times 2 is 4. And I've got my 3y. And there she blows. So therefore, we've got y could be minus 3 over 2, or y could be minus 2. So now you haven't finished because we now have to find x. So you're going to have two solutions. So we can say when y equals minus 3 on 2, right, x will be, and you work it out by slapping it into this equation. So it's going to be 2 times minus 3 on 2 plus 7. So that becomes, they cancel, so x is 4. And then when y equals minus 2, you do the same thing, sub that back in. Minus 2 times 2 is minus 4 plus 7, and we get 3. Okay? Okay, for these last two, check your expansion. I'm doing mine quickly, so if there's an error, fear not. You'll get the gist. But let's have a look at, if you equate the real and imaginary, you've got your different sort of expressions now. So again, we look at this and we've got linear, but over here we've got our x's and our y's together. So it's not just your basic linear simultaneous equations. We can simplify this one on the right first, and we can say, well, that means minus xy. In fact, we can pop that, we might as well do that. Minus xy. To get rid of the plus 3, we take 3, so that equals 10. And obviously you could say, well, that's the same as xy equals minus 10. So we're going to either get x or y by itself and replace it in here. Either one is acceptable. I guess y is by itself there, so we can go, well, y equals minus 10 on x. Now when we replace it into this, we end up with 3x. Instead of y, it becomes minus 10 over x. And we have to remind ourselves, how do we solve this? Well, to get rid of the divide by x, we times. So we've got 3x squared, take 10 equals x. Let's get everything over on one side. Okay, and now we want to factorize. Oops, that's the squared, forgot it. The only way to get the 3x squared is to go 3x times x. And what are our factors of 10? We've got 1 and 10, 2 and 5, but I'm thinking, so 1 and 10 and 2 and 5. So 3 2s are 6, and that has, if I put the, so I've put the 2 there, 3 2s are 6, and then I've got the 5, that gives me the difference of 1. So I want it to be minus 1, so that means it has to be minus 6 plus 5, and then away we go, and you can solve that. Okay, this one, that's going to end up quite nicely, I think, so we'll leave that for you. And from memory, the other question that the students had trouble with was question number 4. And the only trick to this, so this one was you had to write it in the form a plus bi. The only issue with this was where to get started. Now, if you tried to square it straight away, you would have gotten to a little bit of a tangle. So the big tip here is let's simplify this bit here first. Okay, so maybe we could do it to the side. So we've got 4 over, no, don't worry, we'll do it underneath. So we've got 4 over 1 plus I, so we're going to multiply that by 1 take I. Then we've still got our plus 7 take 2i over here, equals, top becomes 4 minus 4i, and down the bottom, 1 times 1 is 1, but positive times negative is a negative, but then it's I squared, so it's plus 1. And we end up having that, that's actually a nice little number there. It's 2, so 4 divided by 2, we get 2 minus 2i plus 7 take 2i. And now you can see it just becomes a simple expansion issue. Okay, so 2 plus 7, 9 minus 4i squared. So multiply that out and there you go. So sometimes try and simplify before you do the expansion. Okay, so see how you go with the rest of those questions, and yeah, you can check with me if you still have any issues. Hope that helps.